Hi students, in this session we are going to discuss about foundations. As you are all aware of, that foundation is the major important element of any building or any structure, as it carries the load and actually it transfers the load from superstructures to substructure. So foundation is the structure which support the weight of the upper structure and applied loads. We are going to discuss about purpose of foundation. The purpose of the foundation is to distribute loads of the structure over a large bearing area so as to bring intensity of load within the safe bearing capacity of the soil lying underneath, like it's below the ground surface. So this is the basic purpose of the foundation, is to distribute the loads which is carried by a structure and transfers to the substructure. It transfers the load of the superstructure to the substructure through ground to ground. The load bearings are phased at a uniform rate to prevent unequal settlements. The load transfers uniformly throughout the structure through foundations. Thus, there will not be any uneven settlements. And to prevent the lateral movement of the supporting material, to secure the level and firm bed for building operations, to increase the stability of the structure as a whole. So this is what is defined as the foundation. So we have different types of foundation. One is shallow foundation and there is deep foundation. So the shallow foundation can be defined as foundation at minimum depth, maybe 1 meter, 2 meters, 1.5 meter. So the shallow depth, the foundation laid at shallow depths, very minimal depth from the ground surface. The deep foundation means when the surface or when you did not get any hard strata at shallow depth, then the foundation has to be laid at greater depths from the ground surface. In this condition, we have to go for a deep foundation. So the examples of a shallow foundation are for transferring building loads to underlying ground, mostly for firm soils or light loads. So when you have good, at least not huge loads, mostly for light loads, for firm soils, we use a shallow foundation. You can see this is the bedrock, this is the firm ground. So the shallow foundations are laid at the minimal depth from the surface of the ground surface. So the examples of shallow foundations are strip footings, pad foundations and raft foundations. These are the three major types of foundations. So the strip footings generally used for light loading, where the intensity of the load is between 15 to 90 kilonewton per meter run. So then we go for strip foundations or strip footings. Pad foundations are basic generally used foundations for medium or light load on a poor ground to good ground. So the intensity of the foundation, the load carried by the foundation should be between 50 to 600 kilonewton per pad on single pad foundation. It can be able to carry that much load. So the raft foundation is like light to medium loading on poor ground. So when more uneven settlements or huge loads are expected, so we'll prefer raft foundation. So then deep foundation. For transferring buildings to underlying ground, most of the weak soils or heavy loads, then we go for deep foundation. So it's the huge structure. You can see we have constructed pile foundations. So to carry the loads, because it's a weak soil, we have to go for foundation until you find a hard stratum, which is generally a bedrock. So the type of deep foundation is piles. We generally call it as piles. So piles are used for medium to heavy loading, such as 600 to 3000 kilonewton per meter per pile, when good ground is only found at depth. So there are different types of piles again. So when the good foundation or good base is available, then it can carry up to 600 to 3000 kilonewton per meter. So the factors affecting selection of foundation. So when you are going to decide on type of foundation, these are the factors which you need to consider. First, the types and intensity of load. So what are the various types of loads are acting on structure and the types of loads and intensity of loads acting on various parts of the structure, which might be dead load or live load, wind load, snow load, what type of load it is and how much intensity or how much is the magnitude of the load. So then it's about the load coming onto the foundation. Then the type of soil or the nature and bearing capacity of the soil, the characteristics or properties of the soil has to be considered. So these are the two major factors we need to consider while selection of the foundation. So let us go talk about strip foundation, strip footings first. Strip footings are used for low rise brick built construction or low rise constructions. Strip is like a strip, like a belt or like a trench, a footing that is longer in one direction than the other. The principle of its operation is to spread the linear load from the wall outside. So it was a wall type of foundation, or we can say that where wall foundations are used, the foundation is laid throughout the length of the wall. So this is a basic strip foundation. The width of such footings are rarely designed but are dictated in standard details within the building regulations. Strip foundations are usually founded at a depth of 1.2 meter, like around 1.2 meter. It is cheap, but it is often slow to construct brick or block walls in a trench. So you can see the examples. Now here if you see the wall, the strip foundation is laid in the direction of wall throughout its length. Simply fills up the trench with concrete to just below ground level and is ready to receive brick and block construction. So it is to transfer the whole load of the wall. So this is much useful for load bearing structures. The next one is pad foundation. So pad foundations are generally used to spread concentrated load. It's like a frame structure. You can see here slab load transfers to beams, beam load transfers to columns, then column load transfers to foundation. This condition generally for loading structures, the pad foundation is preferred, and the pad foundations are used to spread concentrated loads such as from a column, are commonly constructed between 1 and 1.5 meter depth. So pads are simple and cheap to construct. You can see the diagram. This is a column, and you can see this is the pad foundation. It can be a square or rectangle, depends on the design. They are lay above the water table. They do not perform well in poor ground. So it should be these type of pad foundations are constructed in a stable ground. So if it needs connection between each column, like this plinth type of beam can be also constructed to increase the stability of the structure. There are two types of pad foundations. One is laid in differential settlement condition, and the other laid is if the foundation is not loaded in the center. So differential settlement, if the foundation found on a poor soil, then a different degree of settlement may be encountered on each base. The problem can be overcome by, these are the very two problems which may rise while construction of which may rise in the pad foundation scenario. So using pads in reliable known ground conditions. So if the foundation is not loaded in the center and uneven contact pressure is set up, which in itself can cause differential settlements. To overcome the problem, linking pads by ground beams. As I told you, linking pad to like the load is coming on this pad is more than the other pad, so then there is a chance of uneven settlements. To avoid this, like a beam, you can lay ground beam, which is generally known as plinth beam. So it will transfer load equally in the substructure, also avoids uneven settlements. So coming to a raft foundation, it is also generally set as another slab at ground level. So to transfer loads, like how the slab transfers loads to beams to columns and all, so which avoids loading a particular column or loading a particular section. So raft foundations are expensive to construct because they use lot of reinforced concrete. It is only under unusually poor ground. It is only under unusually poor ground conditions. which is used on a lot of reinforced concrete. It is only used under unusually poor ground conditions, that they are used where all the corrective techniques are not possible. So other types of foundations are not suitable and there is a uneven settlement chances, then you may select a raft foundation. It is only used under unusually poor ground conditions, that they are used where all other corrective techniques are not possible. So because it's expensive, where it's also like a laying of another slab at ground level. You can see the examples. This is the example of a strip foundation. This is example of pad foundation. You can see concrete here. This is reinforced concrete here. You can see raft foundation. It's almost like a slab here. This is a trench fill foundation. So now coming to pile foundation. Pile foundations consists of concrete or steel column. So it can be a concrete column, it can be a steel column, it can be a reinforced concrete column placed in the ground. You have seen the pile foundation diagram before, which is placed in the ground like this. Pile foundations are used when the upper layers of the soils are too weak. So a foundation cannot be constructed at lower depths because of the poor soil stratum, where the soil is very poor or weak. In this condition, pad foundations has to be recommended. So used when the upper layers of soil are too weak or uncertain to support pad constructions, or when there are heavy loads to support, a minimum settlement is required. When there are heavy loads to support or minimum settlement is required, we will prefer pile foundations. So you can see pile foundations are often installed in groups of two, at least 2 or 3 or 4, and are joined by a pile cap. You can see, for example, 1, 2, 3, 4. These are piles which are all joined together using a pile cap. On this pile cap, you can construct a column here. This is construction of a column. So this is what is a pile cap. You can see here, this is pile cap. Here, if it is a 2 piles, 1 pile, 2 pile, which is covered by single pile cap. 3 columns can be covered by a pile cap. 4 columns are covered by a pile cap. So this is the top view. You can see the cross view. So you can see 1, 2, 3, 4, 5, 6, 7, 8, 9. Number of piles are here. So pile caps are connected like a slab. On this, columns are constructed. This is a plan view, and you can see the cross section view of the same piles here. Pile caps are in turn joined together with ground beams. The primary function of the pile cap is to spread the point load. You can see the primary function is to spread the point load from the bottom of the column of the structure to the top of the pile. So the column load is transferred to this pile cap. Pile cap transfers the loads equally to all piles and acts as a deep beam covering and distribute between supporting piles. This is the explanation for pile foundation. So this is what we are going to discuss in this class. The base starts from the basic definition and the purpose of the foundation. Shallow and deep foundation, where shallow foundation strip and pad and raft. So deep is all about piles. Again, we will study in foundations part 2 slides about various types of pile foundations and various construction methods of pile foundation, strip, pad, and you might have studied about the types of foundations in previous semesters, such as civil engineering, construction, and also. However, we are going a bit deep into the various types of foundations and its purpose. Let us discuss more in the class session. Thank you.